Okay, we're going to talk about air conditioning compressors and specifically the ones that live in most home air conditioning units. So we want to explore the ruggedness and the various design capabilities of these and some of their limitations. But first and foremost, let's talk about the fact that these are not only the heart of the air conditioning system, but they are also the most durable part in the air conditioning system, and rugged reliability is beyond compare. If you take one thing away from this lesson, take away the fact that when these fail, something else caused it. So with that in mind, let's talk about the types that we have sitting here in front of us. We have a rotary, a scroll, and a reciprocating compressor. And of these three compressors, they all do the same job. And that job is to compress gas for our refrigeration cycle. The fact that they're different is something we need to know because it helps us in our diagnostics and our service. But the fact remains they compress gas. If we look at the rotary, just as a quick overview on the rotary, it's a round steel can. It's completely sealed. They all are completely sealed. They call that hermetically sealed, meaning that we cannot service these. When they fail, we take them out and we replace them. The rotary, for example, is a cylinder, basically a straight, perfectly round cylinder. So is the scroll. The reciprocating compressor over here is not. So the differences between the rotary and the scroll become one thing, and that is this accumulator that's mounted on the side. If you look at the two and you want to know, is it a rotary or is it a scroll, look for the accumulator. It has an accumulator, well then it's a rotary. Internally, they all have a lot of similarities. Whether it's the rotary, whether it's the scroll, or whether it's the recip, they all use oil for lubrication. They all are cooled by refrigerant vapors. All three have protection against excessive heat and protection against excessive pressures. If we think just a moment about the excessive heat, inside each one of these compressors is a motor, and inside that motor lives a thermal element which will click and close, turn off the motor when it overheats. Various reasons might cause it to overheat. Fan motors, dirty condenser, various things can affect that. We also have the pressure situation. It's a sealed can. We don't want the can overpressure, and we don't want the can to explode. We don't want the copper tubing to burst. So if a condition exists and the pressure gets too high, the pressure relief device will open up, will discharge the hot gases back inside the can, and it'll continue to do that process for quite some time. If it didn't do that process, it would probably rupture the copper tubing, and that would vent the refrigerant into the atmosphere, which is against the law. Just for 1 second, just think about what might cause the high pressure condition, and it's the same things that would cause the high temperature conditions. The condenser fan motor not working, or possibly a dirty condenser coil from lack of maintenance. Even hail damage on the coil would cause it. So any of those reasons that cause high temperature or high pressure are dealt with by the built-in safety devices that they all have. I would like to just point out a second that if these were running, if all three of these were running, and we looked at them and we were going to touch and feel them, we would feel differences on each one. The rotary compressor, because of the way it's designed with the pump mechanism in the bottom, it actually would be warm all the way up. The whole compressor mechanism would be warm, and that would be normal. The scroll was completely different inside, so it would not be hot on the sides, but it would be very hot on the top. And I'm going to open the top in a minute, and we'll probably see that. If we look over at the reciprocating compressor, it's going to be pretty much just warm to cool over the entire compressor. The whole motor mechanism sits inside the can and is cooled inside the can, so nothing should be hot except for the discharge line. If you touch a reciprocating compressor and it's very hot, there's something wrong. If you touch a rotary and it's hot on the top but not on the sides, everything's probably okay. If you touch a scroll. If you touch the rotary, it's going to be warm pretty much over the whole thing. Let's take a second and open these up because we want to look inside of them. We want to kind of see what makes them tick. We know they do the same job, so let's look at some differences. If we open the rotary, we'll start with it, and we open the can, we can see the motor. We can pull the motor out and we can turn it. This is actually the stator. It's stationary, doesn't move. And we can pull out the rotor, which is here. But the important part on the rotary is this part. This is what we want to see. If I take this one screw out so we can look inside, we can see the rotary mechanism. I can turn this and we can actually see it turning. There's a stationary vane in there. The gases are compressed around till they have to exit. So that's the rotary mechanism. We'll set it here, and you can compare that to the scroll, which we're going to open up now. If I take the cap off the scroll, we can see inside the cap. Hot gas exits here from here. If we want to, there's the overprotection device right there inside the cap. But the cool part of the scroll is the scroll mechanism. That's this part here. When I open this up, you can actually see the two components. This mechanism rides inside of here. It oscillates. That gives us our scroll compression process, which is very cool. The motor on the scroll is located down low. Pump mechanism's up high. We move on here to our reciprocating compressor. Same thing, welded steel can. I've already taken the motor out because it's heavy and hard to deal with during filming. But you can see, not much magic going on in the top. It's inside the bottom. We'll take a quick look. In here we can see that that's where the oil would be. And we also can see over here, that little device is actually, that protruding copper colored device is the crankcase heater socket. The crankcase heater would fit in there from the outside, and that heater would warm the oil. And if the oil was warm, then liquid refrigerant would not stay in it, and we would prevent some problems that we're going to talk about. The same heater could be in a scroll, it could be in a rotary, and there's various forms of those heaters. Let me open this up so you can see the piston mechanism. I turn this around and lay it here. There's the head. This is the valve plate right here. Set it off to the side. And right here, of course, is the pistons. You can see one of the reed valves fell out on the suction side. But this is the piston. This is like a car motor. And this kind of brings home the fact with these compressors that they are built with that kind of quality. This is built to last. This is built to last the entire life of the system. This is not meant to fail. There was nothing ever designed in here that said I'm going to fail before the system wears out. So take home the fact that if it fails, something caused it to fail. And it was an external cause. It was not the compressor. It didn't just wear out. It was broken because of something else. And that applies to the scroll, and that applies to the rotary equally. Now, when we open these up, it allows us to take a minute and talk about some troubleshooting and some failure causes and some concerns that might come from those causes. So if we talk about the thermal element here, we know that they're protected against heat. So this is that element right here. And they all have it. Somewhere in the windings, each one has an element that will shut it off if it gets too hot. And it could get too hot for a lot of reasons. It could get too hot because the condenser fan's not working, or the condenser's dirty, or hail damage. That's a fact. So this little device would click off. It would stop the motor. The motor would stay off. Now here's the thing. The motor might be off for 1 to 2 hours. So we can't walk up to a compressor that's off on a thermal element and immediately condemn that compressor. We have to wait, give that element a chance to click back on, and then we can test that compressor. Possibly it just needs a fan motor. And the fan motor, sits above the compressor. Fan motor quits. The compressor was affected by it, and now we don't want to go buy a compressor when we don't need one. So that time period between the time that it clicks off and clicks back on might be 2 hours. You can look at here and you can see the mass. It's a big, heavy mass of steel. It's going to take a while to cool off once it heats up. So give it some time. and be patient with it and see what happens before you go out and assume that it's bad. While it's open, I want to point out the pressure relief device that you can see right here. I showed you the one that was inside of the scroll. Here's one on the recip that you can see right in the open. This device would pop and it would just relieve the pressure back in the can. It's very, very obvious when it's sitting open like this. Some other factors to talk about would be moisture. If we get moisture in any of these compressors, as little as 1 drop, we have effectively started killing that compressor. How long that takes could be a month, 2 months, 6 months, but it is going to happen. When it does finally stop, most likely we're going to have a very nasty, ugly mess to deal with. Could have been preventable. Now we need to flush the system and go through various efforts to get those contaminants out. If we don't go through those efforts and we put a new compressor in, very likelihood of the acids coming back and damaging the new compressor are probably 100%. So we want to take those steps. The other item that we would want to also know is, did we replace a compressor that had no oil in it? If it doesn't have oil in it, where did the oil go? It's probably in the system. Most likely we had a flood back condition, and because of that flood back condition, the oil got displaced out of the compressor, and then the compressor died. If we put another compressor in and we did not deal with that oil, it will come back to the new compressor. And when it does, it'll kill the new compressor because it's overfilled. So by dumping the oil out of the old compressor, we can determine if it has its full charge of oil, and if it doesn't, we can take those steps to make sure that we flush it out of the system. So to wrap this up, this reinforced the fact that all of these guys, regardless of the brand, regardless of the style, and regardless of their size, are meant to last the life of the unit. And if they die, and if they fail, there was a cause, and it was not them, it was something else that caused them to fail.